Hello friends, welcome back. So in our Q series, today we are going to learn about extended implementation of queues, which will be circular queue, double-ended queue, and priority queue. So let's begin with first circular queue. Before understanding circular queue, we should understand why we need circular queue. And what do you mean by a circular queue? How can a queue be circular? Then how will someone will be removed out of the queue? Right? You cannot visualize a circular queue being, say, in a bank or somewhere else in real life. Okay, so let's understand how the linear queue works, and then we will be able to figure out what are the problems and why we need a circular queue. So this is an example of a normal linear queue array based implementation. So if you see, I have written three functions: push, pop, peak is fine, and is full. Four functions I have written. So when the queue is initialized, if you see at the right hand side, both B stands for back and F stands for front. So both are pointing to the same element. That means there is no element in the queue, right? And this is the condition for is empty. So if back is equal to front, that means the queue is empty. Okay, and we can say that our size of the queue here is 5. Now we are going to perform the operations that I have written here one by one, and let's see how it works. So first, when we say push 5, so see what I have written in the function for push. So when you are pushing 5, we will say that array of at B will be assigned the element. So B currently is 0. So we will write 5 here, and then we will increment B. So I can say that I will remove B from here and put B here. Similarly, when I push 4, 3, 2, 1, our queue will become 4, 3, 2, 1, and B will keep on incrementing and come here. So the B value would be 5. So you can see that when B becomes equal to size, that means the queue is full. So our queue size is 4. So our queue size is 5. Don't go by 4 because the index is starting from 0. So our queue size is 5, and right now B is 5. So we can say that the queue is full. We cannot insert more elements. So we have done push 5 times. Our queue is full. Now I do pop. When I do pop, see what I have written at the function. We will increment F. Why? Because that's why when we do a pop and do a peak after it, we should get the element which we will get after doing the pop. So when doing pop, I will say that F will come here and this element will be removed. Pop again, I will say F will be removed from here and this element will be removed. F will come out to be here. Okay. Right now you can say that we have 2 empty elements in the queue, but our back is pointing to 5. So although we have elements, but we cannot insert. And that is the limitation of a linear queue of array based implementation. Although we have space, but we cannot insert. So this operation cannot be done. And this is the limitation of an array based queue implementation. You can say that why are we not shifting? Yes, we can, but it is going to take O(n) of time. If your queue has 10 million elements, then you have to shift each element. And that is not very efficient. Now, what I will do is, I will change this implementation and use a circular queue. Okay, so that's how we are going to represent our circular queue. You can see that I have taken one extra element, and that is you can say a buffer element that we need, so that we can separate out back and front. So if I'm going to perform the same elements, because they are going to remain same, same operations for push. So we will push at 5. At this moment, B will be here. Then push 4, 3, 2, 1. Finally, back pointer will come out here. Okay, so I can remove this here, this from here. So this is our state when we perform these 5 operations. And we can say that the queue is full right now. Great. Now, if I do 2 pop operations, that is good. We will remove 5 and we will remove 4, and our F will point to this point. If I do a peek, I will get the correct element. Now, what if I do a push here? Now, I can see that the element is empty. So while doing push, I cannot insert at 5 because this is what we have taken as a buffer. We have to insert at the next element. So here we can have our code. If B is equal to size and Q is not full, then we will say B is B mod 5. This is as size. So with this operation, what we will do is our B will come out to this position. And our condition for is full will also going to be changed. Right? So the condition for is full is not only that B is equal to size, it will be changed with and B mod size is not equal to front. This condition we need to add. If we increment our back pointer and we are not equal to front, then we can say our queue is not full. This condition should be equal to F, not because we are returning if it is full, not is empty. So with these two changes, we can say that our circular queue will work. There would be a change in F also. So when we are doing a pop, we can say F plus plus. So this condition would be F plus plus mod size. Okay, so the problem that we were facing, that we were not able to push 6, is solved because now we can push 6 here and the back pointer will come out here. Just try to understand the logic now. The code we will see in implementation part. I'm just writing a pseudo code here to make you understand. Okay, so this way we are effectively utilizing the entire queue. The second part of video that we are going to cover today is something called double-ended queue. Double-ended queue means if you have a queue, this is our back and this is our front. What we say that in a double-ended queue, you are allowed to do push and pop from both the ends. That's all. That is double-ended queue. So it is an extension of normal queue. In normal queue, you can only push from back and get out from front. In double-ended queue, you just push. You can do push and pop from both the ends. And the third one was priority queue. So I'm not going to cover this because I have extensively covered this in the heap data structure series. Because priority queue is implemented using heap. It is not done using arrays or linked list. So there is an entire video that I've dedicated to priority queue because it is very much important. Why it is used, what are its time complexities, why we are using it, its advantages over normal sorting, everything I have covered. So I request you to please go through that video. I will put a link in the description below. And please refer to that video for priority queue. So that's all for today's video. The important part was the circular queue. Why we use it? What are its need? What problem it is solving? And how it is done. Okay. So thanks for watching. If you have any comments, please put down in the comments below and I will be happy to answer. Thanks for watching. See you again. Bye.